Thank you very much. Good morning. I will be speaking about the Rincon project. This is a project to obtain lithium salts from brines. Project that is similar to the former ones. Rincon Lithium Limitada is the company, and the branch in Argentina is Air Resources. It works with this commercial name in Argentina. I will talk about the location of the mining resources. This subject is important, as our colleague mentioned, from the viewpoint of logistics of the project. It has I have more than 30 years of experience in the Puna Salares, and that's why we believe it is important to consider the location of the mining resources and the logistics for this type of project. Salar del Rincón is located in a zone that is friendly from the logistical viewpoint. It is very near the province of Salta, or the city of Salta, very near Jujuy. It is possible to have access from any of both cities through good roads. Also, it is very near the border with Chile, 15 kilometers from the Sico Pass. The mining gas pipeline and the railroad goes 18 kilometers from the Salar, and through the Salar itself there's a power line that is directed to our neighbor country of Chile. However, it is possible to draw energy from this line. So the location of the Salar is important because costs are reduced fundamentally. There's an optimization of the selection of the production model also. And here we have the summary of what I was saying before. The nearest communities are Catua, Olacapato, Salar de Pocitos, San Antonio de los Cobres. They are the communities where theoretically the taxes paid for an activity of non-renewable resources should go to. This is something that must be taken into account in the mining. The miners do know that when you exploit non-renewable resources, it is necessary to have the provisions for future generations to have enough resources for them to overcome the problems that they could face in the future. And the communities must receive that must have that incentive is the ones that are nearest to the projects. And this is not just the issue of royalty. Royalty is one of the taxes of mining. That is a minimum tax. I'm talking about all the taxes. So here we see a map where we can see the location of Salar del Rincón. Route 51, Route 52 that goes to Chile through the Sico Pass. 51 goes or 52 goes to the Jama Pass. 51 goes through Sico Pass. And here we have the location of the gas pipeline and the location of the station. Another subject that is important in this type of process is climate. The weather of the project site. Importantly, we have to consider the evaporation rate, precipitations, humidity, and temperature. We know that as we come from the north advancing to the south, the salares are each time drier. going south. In the Salar de Rincón, the precipitations, as I remember, the highest one has been 50 millimeters per year. This happened in a single month, but in general, precipitations are below that figure. The salares, such as Salinas Grandes, have a saline crust that is very thick. Each year it dissolves and crystallizes again, and that causes difficulties to have access to the salar in specific seasons of the year, and that shows that the evaporation rate won't be too high in these salares. This happens also in Jujuni, where there's a high amount of precipitation. In order to make a brief summary about the geological evaluation of Salar del Rincón, in 1989, Igarzábal drilled 16 drill holes of 2 inches in diameter at a depth varying between 18 and 62 meters in an area of 64 square kilometers. Based on that, the lithium reserves were estimated in Rincón, based only in Igarzábal works. In 2006, ADI executes 7 12-inch drill holes for pumping tests, and with 14 3-inch piezometric holes at a depth between 37 and 47 meters, and it was observed that the well had a variable porosity in an area of 30 square kilometers. Later, a surface exploration study was made, and all the surface of the salar, and in fact the company controls almost the whole area of Salar del Rincón, there were positive results with concentrations that go between 400 and even 800 milligrams per liter. And as a consequence of those results, what was asked for was the continuing of an exploration program with more holes to confirm these reserves. And this is a map that shows the surface exploration points in an open grid covering the whole salar. Let's talk about the process as such, obtaining lithium carbonate from brines. Basically, there are two forms on how to do this. We selected the process to treat brine, attacking the insolubles, and the stages that followed were the development of the process chemistry made with lab tests, then the conceptual engineering to identify the technical economical viability of the project, and obtaining the operational parameters. A pilot plant was created. Then the basic engineering to define requirements, specifications, schedule, and economic valuation. And finally, the detailed engineering to develop the specifications and drawings, sizing, and equipment lists for the final plant. Something very important, and perhaps this is something that can be solved through the experience in mining for many years, in the development of all and each one of the stages. The guiding principle used was minimization of the loss of working capacity. This is very important because this variable, that is a thermodynamic variable, is fully quantifiable, and the loss of working capacity that is dissipated in the system is dissipated within the ecosystem where the process evolves. And this means being accountable in the production, because it is possible to quantify and put limits for that loss in working capacity is not above the values that would transform that into environmental contamination, because there could be hazard for human health or the environmental balance. And of course, this means having a sustainable mining to have sustainable economies. A sustainable economy is directly related with time, of course, something very important. Then we have the chemistry of the process. Basically, there are two forms to separate the lithium in a solution that is relatively pure, for example, using molecular filters or treating the brine with reagents to reduce the impurities. In the last case, that is a case we have applied, the minimization of the loss in working capacity achieved when there's a maximization of lithium recovery. This is fundamental, the maximization in the lithium recovery from brine. Regarding the lab tests, we obtained the phase diagrams. We optimized the regulation of calcium ion concentration to ensure the precipitation of other impurities, and that optimization was phased firstly theoretically using models that allowed to see the activity coefficients and Pitzer correlations. Also, we tried to optimize the process to obtain and purify the lithium carbonate, and also to maximize the degree of recovery of lithium, as we saw before. The lithium recovery contained in the natural brine, and this is maximized analyzing the mass and composition of the water, moistening water contained in the mud, resulting in the treatment process, and the mass and composition of the water retained. The treatment of the brines. The treatment has several alternatives. There are several processes to do the treatment, and there are linear combinations of these processes. It is possible to treat with lime, with water-soluble hydroxide that ensures achieving an adequate pH in the brine for magnesium to be, for example, below the values we intend to have before the precipitation of carbonate. Also, the regulation of calcium ions is fundamental, because there's a solubility balance with the sulfates and the different forms of borates that work at different pHs, and sometimes it's convenient to change the pH of the process in order to prevent the precipitation of any other calcium compound. All these studies then took us 1 year until we optimized the process. Obviously, it's possible to phase a process with cleaning of impurities and then to precipitate the lithium carbonate, and hence obtaining degree of purity that is adequate for the markets. But however, we developed the whole chemistry of the process and the engineering, from conceptual basic up to the detailed engineering, as I said before, trying to optimize and minimize the working capacity losses, and that implies that the production costs decrease tremendously. It's easier to do things well than poorly. I believe that we took our time, and that was very important to develop the optimal process. And here we have a list of almost all the things we tested, except for nanofiltration that we thought was too sophisticated, but we tested the electrolysis of impure brine, which is the additional energy cost in order to define the process that would minimize the loss of working capacity and to achieve the best condition to face the obtaining of lithium salts from brine. Here I show some pictures of the lab. The lab started with a single piece of equipment, tightening system with specialization in lithium. Then the equipment below is an atomic absorption piece of equipment, and RXF equipment that confirms the results of purity of the products with a review of the residuals in the final product. We're completing the construction of a new lab that is in the process of certification. We shall certify the 17025 for some components, basically the lithium carbonate, and obviously this laboratory will also be certified with ISO 9000 standards. The pilot plant and industrial plant, with the results obtained from the pilot plant and with all the conceptual, basic and detailed engineering, took to the construction of the industrial plant that is currently assembled. The construction of the plant was made by stages and trying to cover the market requirements. The market will grow 2-3 times in the next 10 years. And what we are intending to do is to accelerate or to go together with that market growth. This is a view of the treatment plant and lithium carbonate plant. The plant has a higher capacity, higher than the one predicted to start production. At the beginning, it was 1,500 tons per year. That was the production foreseen for the first year. However, if the market requires so, we can immediately expand the capacity. Here we see a view of the ponds used for the pilot plant that are the ones that are in the upper right side, and the other two ponds are the ones corresponding to the industrial scale plant where the brine is concentrated. The concentration process takes between 6 to 8 months approximately. So late this year we intend to start the production. Which are the uses and expected future for lithium carbonate? Here we have a small scheme of the evolution of the demand and how the market will be divided. The market growth will be twofold or threefold in the next 10 years. This is one of the forecasts. Market forecasts, of course, can be many. There can be many alternatives, just as weather forecasts, isn't it? Well, the future today, we have electrical vehicles. And here we have something that was mentioned before. The subject of the use of electrical vehicles means a reduction in the energy consumption. The energy that electrical cars will use will be generated somewhere, but in large power stations, obtaining energy requires 70% cogeneration or combined cycle plant requires that. A conventional car has an efficiency of 35-40%. There will be a reduction there, but it will be necessary to transport the energy. So that's why there's future for other metals related to the energy conveyance. And this is the huge growth of the lithium market due to the use of lithium batteries. And finally, I wanted to thank the organizers of this event for inviting me to this Congress, and I would like to thank all the participants for your attention, and I hope I have contributed in clearing up some concepts that we believe are fundamental for a sustainable mining, a condition that is necessary to develop a sustainable economy. Thank you very much.